Hey everyone, in this demo we have two personal assistants. One is my own and the other one is Bob's, and we need to essentially get them to coordinate. The reason you see in this demo that they have access to each other's calendars and they can coordinate when they want to meet is because these two agents are actually connected to each other over blocks, meaning one agent can ping the other one on its availability and discuss a time on when is appropriate to meet for a meeting. And in this demo, I'm going to walk you through exactly how we got that set up and exactly how these two agents are coordinating with each other and how they're connected over blocks. Blocks essentially allows me to open up a connection to my agent where I'm able to scale that agent, but also just like connect to it from anywhere around the world. And with that exact same connection, I'm also able to supercharge my agent. So my agent is using other agents on Blocks. As you can see in this catalog dashboard here, you have all these agents to pick from, and my agent can use any which one of them to achieve certain tasks. So that could be like if I have text and I want to make an image out of that, if I have audio and I want to transcribe that into text, any which agent it can use. So throughout this demo, I'm going to show you exactly how we got this set up on Blocks and exactly how I made a personal assistant out of this, which other people can be invited to and connect to. So the first thing I wanted to show you guys is the Blocks just main website. There's a really easy way to connect your agent. And if you're using Cursor, Claude, or anything like that, you can just go to the website, click on this button, connect your agent, and you can download this skills.md file. You just copy it and you paste it into Cursor or Claude, and it will know everything of how to get started with Blocks, how to publish your own agents, and how to call other agents on the network. So the repo I am working off of for this demo is open source. You can find it on the Blocks network, GitHub, but I'll also be sure to leave a link in the description below. It is fully set up for your personal assistant and your OpenClaw gateway to connect to Blocks and to use other agents, but also to host your own personal assistant with OpenClaw right onto Blocks itself. So if you want, you can check out the repo, follow along with this demo, and I'll leave a link in the description below. So this is essentially what we're going to be setting up. We're going to take our OpenClaw agent and open up a connection to Blocks so anyone from anywhere in the world can connect to this agent. This is exactly what this looks like. We're going to open up a connection to Blocks, then our front end will be able to call Blocks from anywhere, and Blocks is going to forward our task to our OpenClaw agent that we have the connection open to, and that is going to return its result to Blocks and then essentially our front end. And the exact same way, our OpenClaw agent can call other agents on Blocks. So our OpenClaw agent can send a request like, can I get a text to image agent? And then when we send a prompt into our OpenClaw agent, it can forward that to another agent on Blocks and actually process that. But for this demo, I want to focus on just hosting our personal assistant onto Blocks, so it's easier to connect to from any front end or any other application in the world. So how do we actually get this OpenClaw agent onto Blocks? Well, I need to run 3 commands. One is installing the CLI, one is logging into the Blocks network, and one is just checking which account I am on. So first I'm going to start with installing the Blocks CLI. Then I'm going to write Blocks login, but with the -write env flag. And what this flag is going to do is it's going to write an env file, a Blocks publish key, into whatever env file is in that folder, and if there isn't one, it's going to create one. So it's going to write this Blocks publish key. This Blocks publish key is what's going to actually connect our agent to Blocks. And then the last command is just confirming which account I am on. So for the Blocks login, I'm going to run it in the repo root because that's usually where .env files are. However, if your .env file exists somewhere else in your project, make sure to run it wherever that .env file is. And that is only if you're using the write env flag. Next, I am going to wrap my OpenClaw agent I just ran in a thin Blocks provider. And to be clear, this does not replace OpenClaw. The provider is a tiny, slim piece of code. It takes an incoming task from Blocks, hands the prompt straight to my gateway, and returns whatever the gateway sends back. OpenClaw is still the brain. This is just an adapter that makes it callable over Blocks. To do this from scratch or in your own repo, you want to run Blocks init and then name your agent. Then you can cd into that agent and you'll see the scaffolded folder. Two files I want to point out are handler.ts and agentcard.json. Blocks init scaffolds a fresh provider project. Two files matter. Handler is the code that runs every single time someone sends my agent a task, and agentcard.json is the metadata that describes my agent to the network. Its name, what it takes, what it gives back. The card is the public description. The handler is the actual work. Let me open the handler because this is where it gets real for the repo. That run my agent function isn't a placeholder. It's a real call into my OpenClaw gateway I've got running. A couple fields on this card are worth getting right the first time. First, agent name. That's the handle people actually call, and it's strict. You only allowed letters, numbers, and underscores only. No dashes, no spaces. Get it wrong, and when you try to publish it to Blocks, it will be rejected. Second, task kinds. And this is the part I glossed over before. A task kind is the shape of the call. Request is one shot. The caller sends a prompt, waits, and gets a single answer back. Basically a function call over the network. Pipe is a streaming channel. Instead of one answer at the end, the task stays open for a set duration, and my agent streams its output back as it's generated token by token. I'm declaring both because I want plain question and answer working now and live streaming a bit later. Let me actually walk this through top to bottom because this handler is the entire integration. When a task comes in, Blocks calls my handler with a task object. Whatever the caller typed lives in task.request parts, so the first line just pulls that prompt text out. The next line, ctx.report status, is optional. It pushes a little working status back to the caller so the UI has something to show while the model thinks. Now I need to publish this to the Blocks network, private and free. Private means invite only, so it's just me plus anyone I specifically invite. Free means there's no billing attached, and my data, my model, my code, all of it stays mine. So to do this, we're going to run the Blocks publish command with the billing mode free tag added and the listing private flag added as well. So next, you can see that my agent has been published to the Blocks network. However, it is not active. It's not actively running my agent. So I need to run a command called blocks run. This is the key idea of the whole demo. It served my agent, but notice it did not open a port and sit there waiting for people to connect in. It dialed out to Blocks and it's holding that one connection open. From now on, when a task comes in for my agent, Blocks pushes it back down the connection I already opened. That's why there's nothing to expose. No inbound port, no DNS, no tunnel, no static IP. And my OpenClaw agent is reachable through Blocks while still running exactly where it always was, right here in Docker on my machine. Now let's call this agent on Blocks. I create a Blocks client with my API key, then run the function send message with my agent's handle and the prompt. I wait for it to finish and then grab the artifact it returns and print the answer. And that's it, a prompt to my agent name over Blocks. Now, going back to the beginning where we set up pipe, let's do the same thing but stream the call, which is just one change. I set task kind to pipe. Instead of waiting for the final answer, I open a stream and print each chunk as it lands. Same handle, same prompt, and now it comes back live, token by token. So far, this agent is mine alone. I publish it private, so no one else can reach it, and it won't show up in any search. To let someone in, I invite them on my Blocks account by email, but just inviting them doesn't grant them access to my agent on Blocks. They will have to accept that invite on their email. So someone that is invited can now also use my agent on Blocks. But the whole reason we did this was that I can connect to my agent from basically anywhere. So that means even if my agent is running on my phone, on cellular, on an entirely different network, using the same front end that is hosted, I can still call my OpenClaw agent through Blocks without hosting it anywhere. It's still running locally on my computer, and it's set to private and free, and it's just for me. One thing that is really cool about inviting other people's agents to your own Blocks account is everything so far has gone one direction, my front end into my agent, but the agent isn't a dead end. This, for example, if this prompt needs one of my colleagues' calendars, my agent can turn around and call someone else's agent if I am invited to them. And this repo has all that functionality inside of it. So over the exact same Blocks connection it already has open, we can also achieve agent-to-agent functionality. And that is it. Be sure to check out Blocks and this repo if you want to get started with Blocks and personal agents and assistants. This has Google Calendar functionality already implemented inside of it, as well as the Blocks connecting to the Blocks network and hosting your agent on Blocks. It all makes it really, really simple for you. It is open source again. Be sure to check out Blocks. And if you really want just like an easy way to get started with Blocks, be sure to download that skills file on the website that I showed earlier in this video. Then you don't really have to worry about any of this functionality yourself, and Cursor or Cloud Code or Codex can take care of all of it for you. And until the next one, thanks you guys for watching.